Collections are a feature that is not used very often in RDF. Nevertheless, there are always situations in which an RDF expert should be familiar with this form of data structure. In principle, unordered sets can be described very easily in RDF by simply linking a subject with several objects via the same predicate. But what about ordered sets? For example, how can I model that the Fellowship of the Ring is the first part of the Lord of the Rings trilogy? For this case, we use a special RDF vocabulary called RDF collection. Let's define that we have an ordered list called Lord of the Ring list, which could be classified as such through the type RDF list. We define the first element of the list via the predicate RDF first, which in this case would be the Fellowship of the Ring. However, do not expect that we then connect the second element with something like RDF second. This would be a bad solution, since it is always unclear how many elements a list could contain, and therefore nobody wants an unlimited amount of RDF vocabulary for counting. Instead, we connect our list with a second list via the predicate RDF rest. That list should preferably be a blank node and contains the second element, the two towers, which is also connected via RDF first. With the same principle, we can then define the third part of the Lord of the Rings trilogy. When no elements are available anymore, we define the rest as RDF nil. Now I will show you how to define this structure in Turtle syntax. Let's start by defining the Lords of the Rings trilogy first. So we define the subject Lord of the Rings trilogy, and we can assign a type to it. So for example, something like movie series, and then we assign a list to it. This list can be assigned via a custom predicate, for example, something like has movie parts. And usually each RDF list is modeled as blank node. So in this case, we define a blank node LOTR list. Okay, so now let's define the content of the list. So Lord of the Ring list has the first element, which is called the Fellowship of the Ring. And the rest of it is defined in another blank node. Therefore, we can use nested blank nodes. So in the rest, we have a blank node, which is also a list, and it has the first element, in our case would be the second of the overall list, which is the two towers. And this list also links to a rest, which is another list modeled as blank node. And there we have the element, the return of the king. That was the last element. So the rest is assigned to nil. Now we defined a list containing 3 ordered elements. Perhaps you think this is a very difficult way or complex way of defining lists in RDF, and I agree with you. And therefore, in Turtle, another way exists how to define these lists, which is much easier than this approach. So we can make everything a bit easier by defining Lord of the Rings trilogy. Which links to a list through the predicate as movie parts. So this is the same as in the first variant. However, now we use a bracket, and in this bracket we define each list element. So the first element, the fellowship of the ring. The second element, the two towers. And the third element, the return of the king. And when you import this in your GraphDB triple store, the engine interprets this statement as multiple statements that define the RDF list that we previously modeled. You can try this out. Just save the turtle file and upload it into your GraphDB database. When you uploaded the RDF turtle file in your GraphDB database, you can go to the graphs overview and have a look at the elements. And you see, when you scroll down, that a new statement has been added. Lord of the Rings trilogy has movie parts, and this refers to a node, a blank node. And when you scroll to the blank node, you can see this blank node has an element assigned as RDF first, the Fellowship of the Ring, and a rest, which refers to another blank node. And in this blank node, node 13, the two towers are assigned as RDF first and another blank node as the rest, and node 14 then as the return of the king as the element, and a rest of nil. If you want to learn more about ontologies, linked data, and the semantic web in general, I can highly recommend my Udemy course. There you will not only learn all the basics about RDF, but also about the query language SPARQL, automated inference of new information using reasoning, and developing your own ontology-based apps. You can find the link to the course in the video description.